So far in class we learned two different ways to solve quadratic equations. One is by factoring and the other is by the square root method. The one we're going to learn today is called the quadratic formula, and you probably learned it before. The good about the quadratic formula is that you can literally use it for any quadratic. It will work for every single one. So if you wanted to use this every time, you could. It's probably a little more complicated, a little tougher, and a little longer than the other methods, so that's the downside of it. But up to you. Sometimes you will have to use the quadratic formula. If factoring won't work and it's not a square root method type problem, you'll need to use the quadratic formula. So the first thing I have here listed for us, that's just the general form of a quadratic equation. A quadratic equation is the kind of thing you would plug in your graph or your y equals in your calculator. So that's the quadratic. Those are different types of quadratic equations. Quadratic formula is what we're talking about today. Notice one thing though. A, B, and C are all constants, so they're numbers we just don't have the specifics of right now. But one important thing is that A has to be greater than 0. If you come across one where the coefficient in front of x squared is negative, you're going to have to change that because you can't do a negative A in this problem or in this formula. And if the A is negative, then you need to multiply everything by -1 so you can fix that. And then of course down here is the actual quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. So let's just dive in and do some examples here. First thing I would just recommend you do, make sure it's in the right form. Ax squared plus bx plus c equals 0. Okay, we're good there. Next is to identify the a, b, and c. Here's our a, so a equals 2. Here's our b, so that's -6. And here's our c, so it's +1. Okay, the quadratic equation looks like this. So we simply now plug in our a, our b, and our c where they go. So we get -b, so -6, that'll obviously turn into a positive, plus or minus the square root of b squared, -6 squared, minus 4 times a times c, all over 2 times a, 2 times 2. Now it's just a matter of simplifying. So the -6 becomes +6. Square root of -6 squared is 36, minus 4 times 2 is 8, all divided by 4. 2 times 2 is 4. Now I'll subtract the 36 minus 8 and get 28. I can reduce that radical to 6 plus or minus 2 square root of 7. Pull a 4 out of the 28, square root of 4 is 2. And the last thing you need to do is check and see if there's any way you can reduce the fraction. See if there's anything that all three pieces have in common. Now it's very important you realize that there are three pieces, the 6, the 2 squared is 7, and the 4. And to be able to reduce it at all three of those pieces have to have something in common. And these do. They all have a 2 in common. So I can divide each of those by 2 and get my final answer, which will be 3 plus or minus the square root of 7 over 2. Okay. Keep in mind, this is really two answers. This is really 3 plus the square root of 7 over 2 and 3 minus the square root of 7 over 2. Just instead of writing it twice, or writing two of them like this, we do shorthand by doing that plus or minus sign. But keep in mind that really is two answers. This next example, if you notice, is not in the form we need. Going back to the first page, we need it in the form ax squared plus bx plus c equals 0. This one is not in that form. So the first step is to rewrite it in that form. So I'm going to subtract the 2x and add the 4 over. So it's in the correct form. So I subtracted 2x from both sides, added 4 to both sides. So again, I'm going to label my a, which is 3, my b, which is -2, and my c, which is 4. And the quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. So I get negative negative 2 plus or minus the square root of negative 2 squared minus 4 times a times c, all divided by 2 times a. So as I begin to simplify this, two negatives make a positive, so that's positive 2 plus or minus the square root of 4 minus, let's see, 4 times 3 is 12, times 4 is 48, all over 6. I do 4 minus 48 and it gives me negative 44. I can factor a 4 out of that 44, square root it to get a 2, so 2 plus or minus 2 square root of negative 11 over 6. Okay, now there's a little more work to be done, but I want to pause here, make sure you understand what's going to happen with this negative 11. Technically, we cannot take the square root of a negative number. That's called imaginary numbers when you take the square root of negatives, because there's no real number that can do that. So we're getting imaginary answers here. And that's fine. You get imaginary answers sometimes. And the way we handle that is we simply say, okay, we're going to take the negative out of the 11, so that's negative 1 times 11. And the square root of negative 1 is represented by I. So we get 2I square root of 11 over 6. So again, I'm taking the negative 1 out of the square root, and we say the square root of negative 1 is I. So I basically just pull the negative out and call it I when it comes out. So my last step is to see if there's anything that will reduce, and again, all of them are divisible by 2. So I can rewrite this as 1 plus or minus I square root of 11 over 3. Or, just so you know, one other way it can be written is you could split it up into two pieces and do 1 over 3 plus or minus I squared of 11 over 3. So both of those are equally good. Just be aware if you see it either way that those are the same thing. Okay, one last problem. It says n equals 23.4x squared plus 259.1x plus 815.8. And this represents the number of police officers convicted of felonies X years after 1990. In which year will the number of convictions be 1,000? Alright, so the number of convictions is the n, and we want to know when that will be 1,000. So we plug 1,000 in for n. This is not going to be easy to factor, probably impossible. It's certainly not a square root method type problem. So that leaves us with the quadratic formula. Now the quadratic formula requires that we're set equal to 0. So we do need to subtract 1,000 from both sides. And that will give us 0 equals 23.4x squared minus 259.1x. And let's see, 815.8 minus 1,000. Give me just a second. Gives us negative 184.2. Now we're ready to go and plug it into the quadratic formula. Let's go ahead and mark our A, which is 23.4, our B, which is negative 259.1, and our C, which is negative 184.2. So we put negative B plus or minus the square root of B squared minus 4 times A times C all over 2A. Okay, so here we go. I'm going to first deal with what's inside the square root. So I do negative 259.1 squared minus 4 times 23.4 times negative 184.2. That gives me 84,000. One second, let's go ahead and those double negatives cancel out. So we get plus or minus the square root of 84,373.93, all divided by 46.8. Since we're looking for an actual year, an actual number, we don't want to simply leave it like this. We want to actually find the number. So remember, this is really two answers in one, because we've got 259.1 plus all that stuff, and 259.1 minus all that stuff. So I'm just going to plug this in my calculator. I think I can do it up here. Let's see. Oops, sorry about that. Overshot it. Okay. So we get 259.1. I'm just going to do the plus first, plus the square root of 84,373.93. Then I'm going to divide that answer by 46.8. So I get 11.74 as my first answer. Now let's do the same thing, but let's do minus. Well, remember on the calculator, if you hit second enter, it pulls up previous responses. So I'm just going to hit second enter twice, and then just change this to a minus. And then divide that answer by 46.8. Alright, well, negative years are not going to be helpful. We can't go back in time. We're not Marty McFly. So the negative answer we're just going to throw out. You can sometimes get two positive answers, in which case that would imply there's just two different years where that number would occur. But we're not going to deal with any negative time, so that means we throw that answer out, and we just use our first one, which was 11.74 years. So let's go back to what the problem said. It said, in which year will the number of convictions be 1,000? And it was years after 1990. So that's 11 years after 1990. So sometime in the year 2001 is when you'd expect it. Now don't round up unless they ask you to, because what that really says is it's going to be 11 years. It's going to happen in the 11th year. 3/4 of the way through is what you would expect. So that would imply you're still in the year 2001. Until you actually get up to 12, you're not in the year 2002. So when it comes to asking what year it's going to happen, you just want to go with your whole year. So it would be 11 years after 1990, which would be 2001.